Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about uh, finding the area, finding the signed area, right? So I'll get started with this guys, right? So let's suppose if you have a function and the function is y is equal to sine x. Now you know y is equal to sine x looks something like this. If I just took it from the positive end from you, it looks something like this. Now, if I want to find the area under the curve from 0 all the way till, let's suppose this is again equal to 2 pi. So if we want to find the area from 0 to 2 pi, 0 to 2 pi of uh, sine of x, right? So what will be the area? Now, if I calculate the area, you would know that this area is exactly equal to this area, isn't it? This area will exactly be equal to this area. So that will actually be simply be equal to sine of 2 pi. I'm sorry, it's not sine, so I have to find the antiderivative of sine x. So antiderivative of sine x would be negative cosine of x from 2 pi till 0. So I'll have to find the value of negative cosine of 2 pi minus negative cosine of 0. And as you can see that this is something which will come out as 0. And even if you see geometrically that this area is exactly equal to this area, and I'll get this area to be equal to negative of this area, and I'll get the total area to be 0. However, that is wrong. Why? Because as you can see that the area is not 0, there is some area under the curve, and as you can see from 0 all the way till this point over here, which is 180 degrees from pi of sine x is actually equal to of dx is actually equal to the negative of pi till 2 pi of sine x. So that means what happens is that when we find the area of a curve uh, which actually crosses the x-axis, then we will not have the exact area by using this formula. Then what we need to do is we need to bifurcate these two parts, calculate them separately, and just add the positives. That is what we have to do. So let's see how we do that. Let's go ahead and find the steps of finding such area. So what you have to do is, step one is that you will have to sketch the graph, right? So what you'll have to do is you have to sketch the graph, and from the intervals that been asking you. So let's suppose the intervals are A and B, right? So you have to sketch the graph. Second thing is that you will integrate each region separately. So you will integrate each region separately. So that is what you're going to be doing. Fine. And the third step is add all the terms. Just take the positive. Do not take the negative. Just take the positive. Let's suppose if I have a question, right? So the question is that I want to find out the area enclosed by this form y is equal to x cube minus 1 from 0 and 2. So I want to find out the area of the curve from 0 and 2. So what I'm going to do is I'm going to actually sketch this. So if I've sketched this curve, if x is equal to 0, y is equal to negative 1. As you can clearly see, if x is 0, y is negative 1. So that means this is going to be the point 0 and negative 1. And when y is equal to 0, so you have finding the x-intercept is very important, because that will tell you when the graph goes below the x-axis, when the graph goes above the x-axis. So when y is equal to 0, x cube minus 1 is 0. That means x cube is equal to 1, which means x is equal to 1. So that means the graph cuts the x-axis at this point, right, which is actually equal to 1 comma 0. So now what I have to find? I have to find the area under the curve from 0 till 2. So I have to find the area under the curve from 0 all the way till 2. So that means that would represent this area, and that will represent this area. So what will I do? I'll integrate them separately. I'll find the area from 0 till 1, and then from 1 till 2. So area from 0 till 1 of y dot dx, and area from 1 till 2 of y dot dx, and I will just take the positive. I will not take the negatives at all. So what I'm going to do is I'm just going to integrate x cube minus 1. If I integrate this, I'll be left with x to the power 4 divided by 4 minus x. So this is what I'll be left with here. That is from 0 till 1. And then here, again I'm going to take the modulus only. That is would be x cube, x to the power 4 minus x from 1 till 2. So if I calculate this, the 0 part is just going to remain, it's just going to give me 0, because if I substitute 0 here, it's going to be 0 by 4 minus 0 minus of, this is going to be 1 over 4 minus 1. Fine. So that is what it's going to be. And this one over here is actually going to be equal to 1 over, sorry, first of all, I'm going to be putting 2. So 2 to the power 4 is 16 over 4 minus 2 minus 1 over 4 minus 1. Fine. So if I just go ahead and calculate it further, this is going to give me, this is going to be 0. This is going to be 3 by 4, negative 3 by 4. This negative will cancel. I'll be left with 3 by 4 here, plus this is going to be 4 minus 2 is 2, minus of minus 3 by 4, right? So which is going to be 2 points, this is actually 3 by 4 is nothing but 0.75, right? So this is going to be plus 2.75. So that is 2.75 plus 0.75, which is actually equal to 3.5. Fine. So I suppose you're understanding this point over here. Now if you integrate this all the way from 0 to 2 and try to find x cube minus 1 dot dx, you will not get the area to be equal to 3.5. You'll get the area to be lesser. You'll get the area to be really less. So even if you check that out, you will not be taking a positive sign here. Negative will come and your area will not be equal to this. So suppose you're understanding this point over here, guys. Let's just pick up one more example and let's do this. So let's suppose if you have a curve. The curve is y is equal to x cube minus 3x square plus 2x. And you want to find the area under the area enclosed by the x-axis from lines x is equal to 0 and x is equal to 3. So you want to find this area. So first of all, the first thing that we'll be doing is we'll be plotting the graph. So we'll be finding out the x-intercepts, right? So you can use your calculator to find the curve also. That is something that you can do, or you can actually see as x is increasing, y will also increase. So that means your graph is coming from here. It's coming from here down. Now you have to find the different y-intercepts, right? So if I find the different y-intercepts, and I'll actually try to find it here, you have y is equal to x cube minus 3x square plus 2x. Now if I just factorize this, now remember this is not a factorizing class, so I'll just factorize this. So if I were to factorize this, and what I'll do is I'll put this equal to 0 because I want to find the y-intercept. So if I just factorize this, it's 2 times 1 is 2, so it's x cube minus 2x square minus x square plus 2x is 0. Then you have x into x minus 2 minus 1 into x minus 2 is 0. So I have x into x minus 2 into x minus 1 is 0. So that means it's going to be 0 at 0, it's going to be 0 at 2, it's going to be 0 at 1. So it's going to be 0, it's going to be cutting it 3 times, like at 2, 1 and at 0. So that is how this graph is going to cut. So it's going to cut at x is equal to 2, x is equal to 1 and x is equal to 0. So what I'm going to do now, I'm going to integrate each step differently. I'm going to find the integral from 0 till 1. Then I'm going to find the integral from 1 till 2. And I'm just going to take the positive, nothing more. So I'm going to find the integral from 0 to 1 and 1 till 2. And he says he wants it till 3. So I will find the integral from 2 till 3. That is this. Right. So I'm going to be finding each of them separately and just taking their positive, not taking the negatives at all. So if I find the integral from, and again, if I just integrate this function, x cube minus 3x square plus 2x dot dx, this is just going to be x to the power 4 over 4 minus 3x cube over 3, which is going to be x cube, plus 2x square over x, which is going to be x square. So this is what the integration of this function is going to be. Now what I have to do just is that I just have to find the integral here. So first I'll find from 0 till 1. So if I find from 0 till 1, what can I do? So 0 is just going to give me 0 and 1 since it's b minus a, right? So the one part is just going to be, I have to put 1 here, 1 by 4 minus 1 plus 1, which is actually equal to 1 by 4. So this is equal to 1 by 4. The next part is a 2 till 1. So I'll just do the 2 part and subtract the 1 part from it. 1 part I already know is actually 1 by 4. So the 2 part is going to be equal to 2 to the power 4 over 4. So 2 to the power 4 over 4, which is 16 over 4, minus 8 plus 4. Fine. So this is what is going to be 2 to the power over 4 over 4, because I'm substituting 2 here, minus 2 plus 4, so that is actually going to be equal to 0. So I'm going to have 0 minus the one part. The one part, if I substitute 1 here, is going to be 1 by 4, which is negative 1 by 4. But I just have to take the positive, which means that is again 1 by 4. That means this is again 1 by 4. Now let me find the 3 part and the 2 part. 2 part I already know is actually equal to 0. So I'll just find the 3 part. So if I find the 3 part, I'll substitute 3 here. So that's 3 to the power 4, which is 81 over 4 minus 27 plus 9. So that is going to be 81 over 4 minus 18, right? I multiply this by 4 and divide this by 4. So this is going to be equal to 81 minus 72 over 4, which is equal to 9 over 4. So that means this is 9 over 4. And if I add individual sum of areas now, 1 over 4 and 1 over 4 and 9 over 4, so that is just equal to 11 over 4 square units. So that means the area here, here and here, the sum of the areas is just equal to 11 by 4 square units. So suppose you're understanding this point over here, guys. So thank you very much for watching this video. In the next video, we're going to be talking about area between two curves. So we'll do that in the next video. So before we sign off, guys, just make sure that you visit our website, that is perfect-course.com. Watch the videos there; it's all organized and everything. Like us on our Facebook page and give us your valuable feedback on this email address. So thank you very much for watching, guys. I'll see you in the next one.